in pre-calc. Okay, so once you separated and got the dy with the y's and everything else with the dt, and when I say everything else, I mean everything else. A lot of people, even after we do these problems, will keep stuff over here, and I promise you it creates a mess. So the easiest thing to do if you have a scalar is always throw it on the other side. Because then what can we do to both sides? Integrate. Because our goal is to solve for y. What's the integral of 1 over y dy? ln absolute value y, yep. What's the integral of k dt? kt plus c. Now we have to solve for y. What can we do to both sides to solve for y? What can we do?
Raise it to the e, like to the e under it.
Put the e under it. It's called exponentiating. Ouch. Yeah. We're basically raising the sides, making the sides exponents, and our new base is going to be e, because what is e to the ln of the absolute value of y?
The absolute value of y.
Just the absolute value of y. Good. Now, the other parts, the e to the kt plus c, what do I know it's always going to be? E to anything is always going to be what? Positive. So I can lose the absolute values because I know the right side is always going to be positive. So I'll end up losing those absolute values. Now here's something we need to be really careful with. This is the whole exponent. This is where we're going to make some mistakes. We need to use properties of exponents. Okay? My properties of exponents tell me that if I am adding the exponents together, when I was multiplying the same base, those had to be the exponents. What a lot of people are going to do incorrectly is, there's a mistake that students make a lot. Oh, they'll just put plus c, okay? But it means e to the kt plus e to the c. Now I'm going to have a couple c's come into this, so what I'm going to do is I'm going to make this first one c1, just so I can distinguish between using a c and a new c. What is e to the c1? What's e to some number we don't know? Some number we don't know. I'm going to put that out in front and call it big C. So big C was e to the c1. I'm just going to replace that with a constant c, and then e to the kt. What formula does it look like that we know? PERT. It looks like PERT, doesn't it? It looks like the continuous compounding formula, and it is. Okay? But what we did is just went from a differential equation. What's a differential equation? From yesterday, what's a differential equation? An equation that has a derivative in it. And what order would this differential equation be? First order, because it just has the first derivative in it. And what we can do is separate and then solve for y. This is the one and only on the AP test that they want you to know this means this, which means y equals c e to the kt. It is the one that they don't have you go through and solve every single time. They want us to know that those things mean the same thing, okay? So what they're going to tell us on that page that you're doing, they went through the same exact steps and just kind of wrote out why everything worked the way it did. Here it is. Know this backwards and forwards. The statement, the rate of change of some quantity y is directly proportional to y, means this differential equation and this solution. Okay? It's the only one on the AP test that if you see this, you can automatically go to that without work. Okay? We're going to see other ones tomorrow where we have to go through and solve all these differential equations. Okay? Any questions there? So we're going to do some applications with it, and we'll go through and solve that a couple times just to make sure that you know how to do it, but then eventually we're just supposed to know that. Okay, so go ahead and read this example about the punctured tire. I'm missing Sid, Leah, Kyle, and Zach. Wow, we're dropping like flies. Don't drop like flies. Where's everyone at? No, Kyle wouldn't be here. Morgan and Bethany, just before you leave, make sure you talk about make arrangements on when you can make up the test. All right, so punctured tire problem, here we go. You run over a nail. As the air leaks out of your tire, the rate of change of the air pressure inside the tire is directly proportional to that pressure. Same statement we just saw, they didn't use Y, they used pressure. So what's the rate of the change of pressure? How would we write that? Rate of change of the pressure, let P be the pressure. What's the rate of change of the pressure? dP dt. Okay, it says that rate of change is directly proportional to that pressure. So what would I write? Equals Kp. Okay, so we want to go from words to that differential equation. Now eventually, we just want to know the answer is going to be y equals P e to the ct, or y equals c e to the kt, okay? But let's go through and solve this one more time just to make sure we know how to do it. What do you have to do first? Separate variables. That means get the p with the p's and the t with the t's. If there aren't any t's, take everything else away from this quantity. So if there is any number over on this left side, put it on the right side, okay? And we'll see as we go, if you don't do that, what happens. So go ahead and integrate. We're kind of doing the work on page 13. There's spaces for it on page 14, but if you're doing it here, we're good. You won't have to do part B on the back. To get rid of the ln, what do we do to both sides? Exponentiate. Why can I remove absolute values around the p? E to the something is always positive, very good, so that's always going to be positive. Now this honestly is the step that we mess up on the most, even on the test, so you want to be really, really careful. E to the c, what are we going to make it? Just plain old c. And then we get c to e to the kt. Okay? Now we have to go back to this problem that says write a differential equation that states the fact that if the pressure is 35, they put an extra pounds per square inch here. So it's just 35 psi, 35 pounds per square inch. Write a differential equation that states that if the pressure is 35 and decreasing at a rate of 0.28, and again, I think they wrote another, you can cross off that one before psi per minute. Okay, so let's take that differential equation from the beginning. dP over dt equals kp. Tell me what dP dt is based on that information. 0.28. 0.28. Is it going to be positive or negative?
Negative.
Good. Since the rate of the pressure was decreasing, we know rate of pressure, that means the derivative of the pressure, so that's our dP dt. And then they tell us the pressure is what? 35. What does that allow us to solve for? K. Good. So we're going to solve for K. This is one that turns out nice, but let's pretend it doesn't. So we need, of course, our calculators for these. We're going to run into numbers that are extremely messy. This one is not one of them, but let's pretend it is, okay? It's going to come out nice to 0.008, but guess what I'm going to do with that right away? I'm going to store it. So I'm just going to store it in A. I don't know if I'll need it again, but if I need it again, I don't have to go back and find out what it is. Okay? Any questions so far? Okay, so what's the K value? I could have actually done this problem and solved that differential equation with that K in there. Okay, so I could have done this. If you want another practice, you can do it with that K in there. But guess what we're going to end up with? P equals C e to the what are we going to put in for K? Negative 0.008t. So this says write a differential equation. Part A says write a differential equation that states the fact that the pressure is 35 pounds per square inch and decreasing at that rate. So this would have been our differential equation. We could plug back in. So part A, I can just say dp dt equals negative 0.008p. Now part B, we did already. Part B says solve this differential equation. So isn't it this answer? Look at the difference. One's a differential equation and one is solving the differential equation. How do you know the difference? What's the differential equation going to have in it? A dp dt, a derivative. When you're solving a differential equation, what are you looking for? The variable itself. Okay. Any questions on A or B? Because then we can go, you have more space now on the back. Now we still have to find out what letter. C, so we're not totally done. What was the original pressure in the tire before it was struck? Ooh, 35. So at time 0, what was the pounds per square inch? 35. What would happen if I put in 35 for the pressure at the time 0? Ooh, what's e to the 0? 1. So what's C? Now I have my perfect equation. It's even better. P equals 35 e to the negative 0.008t. How do I get that? I muddle through and I find K and I find C. Okay? Now I can use that equation to answer anything that they ask me for. So part C says, what will the pressure be at 10 minutes after the tire was punctured? So what are we going to put in for part C? Where's 10 going to go? In for T. And we're going to do this on our calculator. 35 e to the negative 0.008. I'm going to pretend that that negative 0.008 was messy. Where did I store it? Yes, I'm going to do 35 e to the A times 10. And get to 3 decimal places. 32.309. And what would the units be for pressure? PSI. Good. Okay, so I kind of did a mess there for A, B, and C, but that was A, B, and C. Now part D says the car is safe to drive as long as the pressure is 12 pounds per square inch. Erase that other pounds per pounds. For how long after the tire is punctured can you drive safely? So that equation that we just found, P equals 35 e to the A t. How are we going to solve to find out the time when it's going to be safe to drive? And this is where the pre-calc part is going to come in because we're going to solve a lot of equations. Where does the 12 go? In for P. So we're going to go through how do we solve an exponential equation. Now we've talked about it already in the last chapter. But the first thing we have to do is what? Divide by 35. And I want to solve for a t, so how do I get that e thing out of the way? What can I do to both sides? ln. Good. Now that's just flat. That's like ln isn't an exponent, or it's just flat with ln of 12 over 35. But what happens on the other side? What's ln e to the negative 0.08t? Yeah. And pretend if this is messy, remember that's stored in A. So now to solve for t, what are we going to divide both sides by? A, right? So you have to be careful with the calculator. You have to do ln, and then it will give you parenthesis for the 12 divided by 35. Then you want to divide that answer by A. Three places, what do we get? 133.805. The units were minutes. So you have a good long time. You can still drive. A little over 2 hours. Okay? Any questions there? We're going to do another problem just like that, where this is called exponential growth and decay. Of course, this one was exponential decay. How do you know the difference whether it's growth or decay? Your C e to the kt formula, which is the same one you're going to work on all the problems, I think, for tonight. How do you know if it's growth or decay? C e to the kt.
If k is positive or negative.
Yeah, if k is positive or negative. Because think about if you were asked to graph e to the x. What if we were graphing e to the negative x? Okay, so that k value tells us whether it's growth or decay. All right, so let's try this next one. Bacteria in a lab. Culture grows in a way that the instantaneous rate of change, that still means what? The derivative, right? The instantaneous rate of change of bacteria is directly proportional to the number of bacteria present. So if they asked this on the AP test, if they said part A, write the differential equation that expresses this relationship. And let's let P again be the population of the bacteria. Or we could let it be B. Maybe number of bacteria, let's let it be B. What would the differential equation be? dB over dt is directly proportional to the number of bacteria. Yeah, same formula that we saw before, but we saw it's the first time with dy dt over dt equals k. Okay. Times y. Then we saw it on the last one, dp over dt equals k times p. Now we're seeing it a third time. Do we need to solve it again? Are you sure? Can you separate and solve it? So we're going to be separating and solving a lot of them tomorrow. But this one is the only one that's going to come out to be what answer? B equals C E KT. So we'll talk about the homework, and I'll tell you how many of them I want you to solve, because I want you to practice that a little bit more. Okay? But that's the equation we're going to use. So now let's try to use that equation to see if we can answer, because some of these get real messy, especially with the numbers. So suppose that initially there were 5 million bacteria. 3 hours later, 7 million. Write an equation that expresses the number of millions of bacteria as a function of hours. Okay, so they're saying to express the number of millions of bacteria. So they're letting the bacteria be in millions, aren't they? They've kind of told us that. So that makes it a little bit easier with the numbers. Do you know any ordered pairs that will help us with the problem? What's one?
0.5.
0, 5. And what's the other one? Anyone come up? What's the other one? 3, 7. Okay. Which one's going to help us find the C value the fastest? The 0, 5, right? So I'm going to use the 0, 5. What you want to be careful is we're gonna see on this particular one, when t is 0, you always get the initial. It doesn't always work that way, so you wanna be careful just to make sure you check it. But c is definitely gonna be 5, which represents 5 million, okay? So now how are we gonna find the k? Because now I have b equals 5e to the kt.
We can use 3, 7 for.
Yep, good. What's the b?
7.
7, and what's the t?
3.
3. Now what we're going to do is solve this, and this is where it's going to get a little messy. What do you have to do first? Divide by 5. So we have to do that first. And then what are we going to do to both sides? ln. So I have ln of 7/5 equals ln of e to the 3k. Now ln of e to the 3k is 3k. So we have ln 7/5 equals 3k. K is ln of 7/5 divided by 3. That's exact. When I throw it into my calculator, I'm going to get an estimation. Okay? I do not want to round that answer yet. So what I'm going to do is take this answer and store it in A. Would this k value be positive or negative? Positive. How do you know that? Ln of something can be negative because the graph, the y values live below, so it can definitely be negative. We just talked about how do we know if it's growth or decay. Brandon?
We're increasing the population.
The population's increasing, so the k value is going to be positive. The tire air was leaking, so the k value was negative. Yeah, when you ln of your ln answer, what you can't do is you can't ln a negative number. But the answer out of an ln can be negative because the graph of the ln looks like this. So you have some negative values for y. Okay, so we have our equation now. We have y equals our c value, which we found was 5, e to the messy number, ln of 7/5 over 3 times t. So that is the equation. So that's part C, right? The particular equation that expresses the number of millions as a function of hours. Now part D says to graph it. I know my graph's over there, but I'm just going to throw it here. Anytime we graph, we want to label. What does the x-axis represent? Time. And it was in hours, okay? And the other side was the population of bacteria in millions. That millions is important because it started at how many millions? 5. And then after time 3, it was up at 7. And I don't really have to do much else. I mean, I could figure out at time 10 what it would be. But do you know, because it's going to go up to time 10 based on what they're asking us to do. Over the 10 hours, okay? So I could plug in 10. So I already stored that in my calculator. So I'm going to do 5 times e to the 10a. So I stored it. So I'm going to try to make it easier for myself. And then I can figure out what that value is. Like 15 point something. Get that? So if we graph that, we know since it's exponential, I'm not going to figure out exactly what it's going to be, but it's going to go exponentially, so it's going to go up. Okay, so let's try to do E and F. See if you can, using the equation, 5e to that k value times t, figure out the bacteria after one full day. And then see if you can figure out when the population's gonna reach 1 billion. For a full day, how many hours would that be? Yeah, 24. So I'm just gonna plug into my calculator, 5e to the 24a. Oops. Notice when I'm changing to the squiggly equals as opposed to this is exact. Did you get 73.789 million? Okay, and then F, where are we going to put 1 billion in? The other side, but do we want 1 billion? 1 billion is how many millions? 1 billion is 1,000 millions. So what are we going to put instead of 1 billion? 1,000, yep. These are the harder ones. This is like the pre-calc stuff is going through and solving this equation. So you have to divide first by 5. And I suppose if you labeled that this was A and you kept using A in the equation, that would be all right as long as you clearly labeled it. Then you have to do what to both sides? ln both sides. Yeah, I'm going to make that an A. And if you use the capabilities of your calculator, it really does make it a lot easier. Just make sure that you also, after, like, you close the parenthesis for the ln, so you get the right answer. It's 47.240, and time was in hours. Okay? Any questions there? So that's exponential growth. So the only calculus part is that dy dt equals ky, solving it to get y equals c to the kt. And all the other stuff is using pre-calc. Okay, to solve it. So when you go to do your homework, this is going to be in the packet. So tonight it's going to be packet pages 15 to 17. The final answers are in the packet. I put out worked out solutions on black. Okay, so 45, they're starting us off with these little differential equations that we're going to build on as we go through the chapter, and they'll give us some more complicated ones. But for right now, the first step you had to do was throw the dx on the other side. And then you can integrate dy to get y. To integrate this, you had to do monomial division, and then it could integrate. Now they in the answer put the two, they used properties of logs and swung that 2 up as an exponent. Okay, another number from the bookwork. 13. Okay, so 13 gives you this y equal the cosine of 2x, and then they give you this formula. It's been a while since we've seen things like this, but this means the 4th derivative. They run out of tick marks for derivatives after the 3rd, so that if you see a number, it means the 4th derivative. So I had to take the 4th derivative of y, 1, 2, 3, 4. I threw the 4th derivative in, minus 16 times the original y, and all I'm doing is checking to see if it's a solution or not. It was not a solution, because it didn't give a true mathematical statement. These are the ones, for whatever reason, on the test people will miss. You know, just plugging them in and checking. You want to think if you solved an equation and you got x equal 2 and someone said check it, you'd put it back in. Same thing. If you get a solution to a differential equation, if you plug it back in, does it work? Okay, another. Slope fields is this really, really interesting topic that they started testing on the AP test a ton. And that's what these pages were on.
Okay, for like 15 through 18, those are all the ones where you're trying
Yes. Okay, let me show you a trick. Okay, so let's jump to 15 to 18. This is page 8. They want us to be able to match these. So the first thing I would do is pick out the ones that are going to be easier. The ones that are going to be easier are the ones that don't have an X and a Y. If they just have an X in it, they're going to be easier. So like I'll just do one. I'll say if X is 0, okay, anytime X is 0, my slope should be 1. So I'm going to look at my graphs. When X is 0, the slope should be 1. I know it's not C. When X is 0, the slope should be 1. I know it's not A. Okay, so now I'm between these two. When the slope is 0, it's always 1. Oh, it can't be this one because there's some negatives. So I just pick a really easy value, normally 1s and 0s. Okay, so I can figure out what that one is. Now I'm going to go to 16. I'm going to pick out when Y is 0. Okay, if Y is 0, what's the slope always going to be? 0. So when Y is 0, I want to know when the slopes are 0. I know it's not C, and you might look at it and not be sure if it's A or D. You don't know what's going on at 0. So I know it's not this one. So now I'm between A and D. So now I'm going to pick another one. When Y is 1, the slope is 1. So I want to look when Y is 1, all of those slopes should be 1. So guess which one it is? D. Okay? Now to go to the harder ones, X minus Y. I'm going to pick like 1, 1. At 1, 1, what should the slope be? 0. So at 1, 1, the slope should be 0. I know it's not that one. At 1, 1, the slope should be 0. I know it's not that one. At 1, 1, the slope should be 0. Aha, it's that one. At 1, 1, it's not that one. So I can just with 1 point pick that one out. Now I might have to pick more than 1 point. For this one, I'll pick 1, 1 again. Okay? If X and Y are both 1, what's the slope? Negative 1. So I'm going to look here at 1, 1. Slope's not negative 1. 1, 1, slope's not negative 1. 1, 1, slope's not negative 1. 1, 1, haha, slope's negative 1. So I can very quickly match those up just by picking points. So that's a good, so you want to be able to do that so those aren't difficult. Okay, once you pick a point or two. Okay, what other numbers in that packet? Let's go back to 4. How was that one? I just look at it and say, okay, which ones are true or false? For X is less than 0, are all the solutions decreasing? For X's are less than 0, are all those slopes decreasing? There's a whole bunch of them increasing, right? Because X is this way. So when X is less than 0, it's looking for all these left of the y-axis. All solutions level off near the x-axis? They do. For y is greater than or equal to, or y is greater than 0, are all the solutions increasing? Above the x-axis, they're all positive. Yep. So I just kind of go through and figure it out that way. How is number 5? Eyeballing what that would be. I kind of thought at first it could be A, but then I looked and the slope would have to be 0 here, and it wasn't, so I could eliminate it. So I was in between these two. Okay. Number 6, how was that? Vertical segments are going to happen when the slope is what? Undefined, which means the denominator is going to be 0. So I just solved that. Okay. So bring them this tomorrow so that if you have questions,